Imagine your garden. Maybe it's just a small backyard, a patch of land behind your house where you grow a few vegetables or a couple of tomato plants. Now imagine something else. In one corner of that garden, there is a small pond. It doesn't have to be large, just a few square meters of water. Inside the pond, there are a few fish, some aquatic plants, maybe even a few ducks swimming on the surface. At first glance, it just looks like an ordinary water feature in a garden. But the surprising thing is this: that small pond could produce food for your family for many years, without heavy feeding, without machines, without chemical fertilizers. It sounds almost unbelievable. But more than 2,400 years ago, a Chinese farmer named Fan Li wrote about this exact system in a book called Yung Yu Jing, the classic of fish culture. In that book, he described a remarkably simple system. With just a small pond, if it is built correctly, it can produce more protein than livestock raised on the same amount of land. All it needs are four things: water, sunlight, living organisms, and time. Once established, the ecosystem inside the pond can sustain itself for decades. In many ancient Asian villages, ponds like these existed for hundreds of years, continuously producing fish and food for the families around them. But strangely today, very few people even know this system exists. When humans learn to observe nature, to understand how this system began, we have to go back nearly 3,500 years before the Common Era, along the Yellow River. At that time, farmers often noticed something interesting. After seasonal floods, when the water receded, small depressions in the land would remain filled with water. Inside those pools, fish became trapped. What surprised people was that the fish did not die. They survived perfectly well. They continued to grow and reproduce. And when villagers needed food, they could simply catch fish directly from those small pools. Farmers began experimenting. They dug the depressions deeper. They packed clay around the edges to help hold the water. And gradually they discovered something important. If the pond was deep enough, fish could survive there all year long. This was not agriculture in the modern sense. This was careful observation of nature. Humans did not invent the system. They simply allowed nature to do what it already wanted to do. The first fish ponds of early civilization. By around 1600 BCE, during the Shang dynasty, fish ponds had already become part of agricultural life. Archaeologists later discovered ancient inscriptions carved on oracle bones. Among those writings was an interesting phrase, fishing in the garden. At first, many scholars believed it was simply a poetic expression, but later research revealed that it actually described managed fish ponds located directly inside household gardens. At that time, wealthy families raised ornamental koi, ordinary farmers raised carp for food. Both systems involved ponds, but only one of them actually fed people. Around the 7th century, during the Tang dynasty, something unusual happened. The emperor's family name was Li. In ancient Chinese pronunciation, carp had a very similar sound. According to tradition, raising or killing an animal whose name resembled the imperial family was considered disrespectful. So the court issued an order. Carp farming was forbidden. For farmers, this was a serious problem. For more than 1,000 years, carp had been their primary source of protein. But instead of abandoning their pond systems, farmers did something remarkable. They began raising multiple species of fish in the same pond. For example, fish that eat plants near the surface, fish that filter algae in the middle layer, fish that consume plankton, fish that feed on sediment at the bottom. Each species lived in a different ecological layer of the pond. There was no competition. There was no waste. Every species used a different part of the ecosystem. This became the first multi-species fish farming system in the world. Today we call it polyculture aquaculture, fish ponds that lasted for centuries. By around the 12th century, when European merchants and explorers began traveling through China, they recorded something that surprised them greatly. In many rural areas, they saw villages surrounded by fish ponds. These ponds were not temporary structures or newly built farms. Many of them had existed for generations. Some ponds had been maintained for hundreds of years, passed down from one family to the next, and despite their age, they were still producing large quantities of fish every year, providing food for entire households and sometimes for the surrounding community as well. What amazed outside observers even more was how simple the system appeared. The farmers were not bringing large amounts of feed to the pond. There were no machines, no pumps, and no complex equipment. No one was feeding the fish. Instead, the ponds functioned as self-sustaining ecosystems where sunlight, plants, microorganisms, and natural food chains produced everything the fish needed to survive. In other words, the pond fed itself when the knowledge was forgotten. When Europeans later migrated to North America, they brought with them the livestock systems they were familiar with: cattle, pigs, and chickens. These systems require constant inputs. Animals must be fed every day. They require shelter, and they need continuous labor and care. Over time, this model became the dominant form of agriculture. As a result, the idea that a small pond could produce food, especially fish, seemed too simple to be taken seriously. In many parts of the world, fish had long been a major source of protein, raised directly in household ponds. But in America, ponds gradually stopped being viewed as food-producing systems. Instead, they became decorative ponds, koi ponds, or garden fountains. They added beauty and tranquility to the landscape, but they did not feed anyone. And slowly, the ancient knowledge of self-sustaining fish ponds that could feed a family began to disappear. In the 1960s, when many countries began worrying about global food security, a group of scientists at Auburn University in Alabama decided to revisit an ancient idea: raising fish in small ponds as a household food system. Instead of building large fish farms, they started with very small experimental ponds. Each pond was about 1,000 square feet, roughly 90 square meters, about the size of a small backyard swimming pool. The ponds were built with an average depth of 1.2 to 1.5 meters. This depth helps stabilize water temperature and allows fish to survive throughout the year. The researchers stocked the ponds with common native species found in the southern United States, mainly bluegill and channel catfish. These fish are well adapted to natural pond environments. They can feed on insects, plankton, and algae naturally present in the water. When researchers measured the results over the following years, they were genuinely surprised. These small ponds could produce up to 350 pounds of fish per year, about 160 kilos of fish from only 90 square meters of water. For comparison, a much larger piece of land used for raising cattle typically produces only around 200 pounds of meat per year, and cattle farming requires many inputs: supplemental feed, veterinary medicine, barns, and fencing to manage the animals. Meanwhile, these ponds operated almost entirely on their own. Most of the fish's food did not come from humans, but from the natural ecosystem in the water, where sunlight grows algae, plankton feeds on algae, and fish feed on those tiny organisms. In other words, the pond is not just a place to raise fish, it is an ecosystem that produces its own food. This pond system works through four main components, all connected within a natural biological cycle. The first component is ducks. Ducks do more than simply produce eggs. As they swim across the surface of the pond, their movement gently stirs the soft sediment at the bottom. This releases nutrients that have been trapped in the soil. Their manure also plays a very important role in the ecosystem. Duck manure contains nitrogen, which dissolves into the water. That nitrogen becomes a key nutrient that helps algae begin to grow. And once algae begin to grow, they form the foundation of the entire food chain inside the pond. In other words, the ducks are not just animals living near the pond. They are actually one of the engines that keep the whole ecosystem running. Nitrogen helps algae grow. The algae then become food for plankton. And the plankton, in turn, become natural food for fish. With just a small flock of about 3 to 5 ducks, a household pond system can produce around 800 to 1,700 eggs per year, while also supplying nutrients that keep the entire pond ecosystem functioning. The second key component of the system is aquatic plants. These plants function like a natural biological filter for the pond. Several species are commonly used in pond ecosystems, including cattails, water lilies, and duckweed. Their roots absorb excess nutrients from the water, especially nitrate and phosphorus. By removing these nutrients, the plants help keep the water cleaner and more balanced, which allows fish to stay healthier and grow more reliably. Aquatic plants also provide shade and shelter, creating a more stable environment for the pond ecosystem. One plant that plays a particularly important role is duckweed. Duckweed is known as one of the fastest growing plants in nature. Under favorable conditions, it can double its biomass in as little as 48 hours. Because of its rapid growth and high protein content, duckweed becomes a natural food source inside the pond. And interestingly, ducks love to eat it, which helps connect the plant layer of the ecosystem with the animals living above the water. The third component of the system is fish. In many household ponds, farmers usually raise a combination of species rather than relying on only one type of fish. Some of the most common species include bluegill, catfish, and tilapia. Each of these fish behaves slightly differently in the pond, and those differences help make the entire system more stable and productive. Bluegill are often considered the backbone of small pond ecosystems. They reproduce naturally and can spawn several times during the warm season. Because of this, their population can maintain itself over time, creating a self-sustaining fish supply without the need to constantly add new fish. Bluegill also feed on small insects, plankton, and tiny aquatic organisms that naturally live in the pond. Catfish, on the other hand, are known for their hardiness and adaptability. They tolerate a wide range of water conditions and are comfortable feeding near the bottom of the pond. Catfish grow steadily and can reach a good harvest size even in relatively small backyard ponds. Their diet often includes insects, organic matter, and small organisms living in the sediment, helping recycle nutrients within the ecosystem. Then there is tilapia, which are famous for their extremely rapid growth rate. Under warm conditions, tilapia can reach about 1 EOB in just 5 to 6 months. Tilapia are also efficient feeders. They consume algae, plant material, and plankton, allowing them to convert natural pond productivity directly into fish protein. When these species live together in a balanced pond, they use different parts of the ecosystem and different food sources. As a result, the pond becomes highly efficient. Much of the fish's food comes directly from the pond itself. Insects, algae, plankton, and other microscopic organisms that naturally develop in the water. Because of this, the pond does not behave like a traditional fish farm that depends on constant feeding. Instead, it functions more like a small living ecosystem, continuously producing fish as part of its natural cycle. The final component is beneficial bacteria. Although they are invisible to the human eye, they form the foundation of the entire ecosystem. These bacteria transform waste in the water through a natural biological process. Ammonia to nitrite to nitrate. This process is called the nitrogen cycle. It is the mechanism that keeps the ecosystem balanced, turning waste into nutrients that feed plants and other organisms. When these four components work together, the pond becomes more than just a place to raise fish. It becomes a self-sustaining food ecosystem that can function for many years. Building a food pond. One of the most interesting things about this system is that you do not need a large farm to build it. A household pond can actually be quite small. For example, a pond measuring about 10 ft by 15 ft with an average depth of 4 to 5 ft is already large enough to create a stable environment for fish and other living organisms. That is roughly the size of a small corner of a backyard. Despite its modest size, a pond like this can support a surprisingly active ecosystem. The cost of building one is also relatively modest. In many cases, the total startup cost ranges between $400 and $600. This typically includes several basic elements: a waterproof pond liner to hold the water, a small number of starter fish, a few ducklings if ducks are part of the system, and several types of aquatic plants that help filter the water and balance nutrients. Once the pond is established, however, very little daily work is required. Sunlight fuels plant growth, microorganisms begin to develop, and natural food chains start forming in the water. Over time, the pond becomes a living ecosystem that largely takes care of itself. After the pond is built, the ecosystem does not become stable immediately. Nature needs time to establish balance. During the first 6 months, the different components of the pond begin to stabilize. Aquatic plants develop roots, microorganisms multiply, and the nutrient cycle starts to form. At first, the water may appear slightly cloudy, but this is often a sign that the ecosystem is beginning to function. After about 1 year, many fish in the pond will reach a harvestable size. By the second year, fish populations often begin reproducing naturally. This means you no longer need to continually add new fish. The system starts maintaining itself. By the third year, the pond becomes a nearly complete ecosystem. At that point, it no longer feels like you are managing a farming project. Instead, you are simply harvesting food from a living ecosystem in your own backyard. One important detail many people forget: if you live in a cold climate, the pond may freeze during winter. However, fish can still survive beneath the ice as long as there is a small opening that allows gas exchange with the air. Fish species, such as bluegill and catfish, are relatively cold tolerant and can survive the winter in a semi-dormant state underwater. Tilapia, on the other hand, are tropical fish. They cannot survive very cold water, so they usually need to be harvested before winter arrives. But the most important aspect of this system is not just the fish, and it is not only the eggs. The real value is independence. When you have a small food ecosystem in your backyard, you are no longer completely dependent on supermarkets, supply chains, rising food prices. Instead, sometimes all you need to do is walk into your garden, drop a fishing line into the pond, and harvest your meal directly from nature. More than 2,400 years ago, Fan Li understood something very simple. Nature does not need us to control it. Nature only needs us to cooperate with it. A small pond, a little sunlight, a living ecosystem, and patience. Sometimes the most powerful food systems are not the most complex ones. They are the systems that have quietly worked for thousands of years. If this story changes the way you look at the potential of your own backyard, please subscribe and like the channel. We are uncovering the history and systems that have been overlooked for too long. Let's cultivate the future together. The next treasure of knowledge will be revealed soon.